I hope you are doing well, my dear students. Welcome back to Jennifer Chemistry Official, where we make chemistry friendly to all our learners. Today, I want us to go through this subtopic on ionic equations. From our previous lesson, I already promised you that I'll be guiding you through the formation of ionic equations. But before we go to the writing of the ionic equations, there are these major points that you need to take note of. 1. Ionic equations. There are these equations obtained by writing only those ions that undergo change during a chemical reaction. They are formed during a precipitation reaction used in the preparation of insoluble salts. So note that we have the formation of insoluble salts. From our previous lesson, we already said that where we have insoluble salts, we put a state symbol, which is a small s into bracket. Precipitation reactions are reactions in which solids are formed from aqueous solutions. The solids formed during a precipitation reaction are known as precipitates. The ions that remain unchanged during a chemical reaction are called spectator ions, and these ions are usually omitted when you're writing ionic equations. So take note of these major points, and so that it will be an easy time for you when you're writing the ionic equations. Next, we have this NB, which is very important for you, that in a precipitation reaction, or rather when writing ionic equations, two reactants must be soluble salts, that is, they're in the aqueous state, but on the product side, one salt is soluble in the aqueous state, while the other one is insoluble in the solid state, that is a small s into bracket. Then next we have this question that will be guiding us through in the simple steps that we follow when you're writing ionic equations. So we have this question that says, when lead 2 nitrate and magnesium sulfate react, a white precipitate is formed. Identify the white precipitate. Remember, for the precipitate, it is like to be asked among the products, which of them will be in the solid state, or rather which one will be insoluble. So this is how we do it. We take the two salts. So red has nitrate as the radical. Magnesium has sulfate as the radical. So the two will be reacting. They are the reactants. Once you go to the product side, lead will be taking the sulfate from the magnesium, while magnesium will be taking the nitrate from lead. And once you do that, it will be very easy to determine which of them will be a precipitate. And again, being guided by the song or the mnemonic that I provided for you in our previous video. So if you are new here, please go back to the previous lesson. You'll know how solubility of salts is determined. And again, you get a song that you can sing anytime you want to remember which salts are soluble and which salts are insoluble. So let us write it together. So this red will be taking the sulfate from magnesium, while magnesium will be taking the nitrate. So that once you do that using the arrows, you'll be having an easy time when writing the products. So from the reactants then we get red taking the sulfate, so one of the products will be red 2 sulfate, plus magnesium will be taking the nitrate, so plus magnesium nitrate. So that is how we do it. Lead takes the sulfate while magnesium takes the nitrate. Once you do that, then you go back to the song that we use when we want to enhance our memory about the solubility of salts. And the part that is very important for this question is about the sulfates and about the nitrates in that song. So about the nitrate, we say that all nitrates are soluble. All nitrates, all of them are soluble. So meaning, now that we have magnesium nitrate in our case, magnesium nitrate is the soluble salt. It is the one that will be in the aqueous state. When we go to the sulfates, we say that all sulfates are soluble except barium sulfate, lead 2 sulfate, and calcium sulfate, which is slightly or sparingly soluble. So you see that among the sulfates, we have mentioned lead as one of the salts which is not soluble, meaning it is insoluble. And those salts that are insoluble are the ones that form precipitates. Because once they form precipitates, they will now be in the solid state. Because any salt that is insoluble, remember we said it is in the solid state. So to answer this question, identifying the white precipitate, this is actually lead 2 sulfate. So that is what we will write as the answer. So it is lead 2 sulfate. That is the answer that we need to have. So I hope you have got the secret behind writing a correct word equation that will take you direct to the answer. So a note or a point to note is that anytime you are asked to determine which of the salts is a precipitate, remember it is any salt that is insoluble in the word equation. And remember now, from the word equation, we will be in a position to write a well-balanced chemical equation that will then guide us in the writing of the ionic equations. So let us now go direct to the writing of the chemical equation in our next question. Here we have a summary of the easy steps followed when writing ionic equations. Number 1, you need to write a word equation. Number 2, you are needed to determine which salts are soluble and which one is insoluble, because it is only one salt that will be insoluble. And B, the salts in the reactant side should be soluble. In fact, we should use the word must. The salts in the reactant side must be soluble in the aqueous state, while one salt in the product side should be soluble in the aqueous state and the other salt insoluble in the solid state. From there, we need to break the salts in the aqueous state into their respective ions and make sure that the charges are well balanced. And B, the salt in the solid state or the insoluble salt should not be broken into ions, as it cannot form ions. So the only ions that we break into their respective ions are only those salts that are in the aqueous state. In case we had an equation that had some substances in the gaseous state or in the liquid state, they could not also be broken down. They are supposed to be left just the way they are in their gaseous or in their liquid state. So the only ones that can be broken are strictly those that are in the aqueous state. Number 4, cancel out the spectator ions. Those are the ions that do not take part in the chemical reaction. They remain unchanged. So, and then there you check on their state symbols. You check on which one has not changed in terms of the state symbol. You cancel it out. And finally, you write the ionic equation, and it will be good if you start with the metallic part, followed by the non-metallic part or the radical that was involved. Next, we have this question that requires us to write an ionic equation. To begin with, we need to write a word equation that will guide us in the writing of the ionic equation, and it is the same word equation that we had in our previous question, where we have lead 2 nitrate reacting with magnesium sulfate and I guided you through to knowing how they'll be exchanging the radicals. So red takes the sulfate while magnesium takes the nitrate. So on the product side we have lead 2 sulfate, lead 2 sulfate plus magnesium takes the nitrate, so plus magnesium nitrate. Let me remind you of something that we said some times ago, that when you are arranging the equation on your book or in future on the KCSE paper, you need to make sure that all the reactants are from this part to the left, where we have the tail of the arrow. From this point, this direction, that is where we have the reactants. So we should not have any reactant going beyond the tail of the arrow. For the products, they should begin where we have the head of the arrow to the right. So that is the product side. So there is no product that should spill to the reactant side. Like now, if you feel that your space is not enough and that any product cannot fit, you cannot bring it to this side. For example, if magnesium nitrate could not fit on that direction, you cannot bring it to the reactant side. So you should arrange your page, even though not necessarily that you should divide it with a line, but you should be in a position to tell that this is where I have the center of the paper, and the products, the reactant should be on the left, while the products on the right hand side. That way you will appear organized, and again you not miss any mark. Next, before we go to the writing of the ionic equation, I want us to analyze this equation. To begin with, we have lead 2 nitrate. We say that all nitrates are soluble, meaning that lead 2 nitrate being soluble, once we write the chemical equation, lead 2 nitrate will be in the aqueous state, a small a and a small q into bracket. Magnesium sulfate, we say that all sulfates are soluble except barium sulfate, lead 2 sulfate, and calcium sulfate, which is sparingly or slightly soluble. So meaning that magnesium sulfate, now that it has not been mentioned among the insoluble sulfates, it is then in the aqueous state because it is soluble. Once we go to the product side, again about sulfates, we say that all sulfates are soluble, all of them meaning they're in the aqueous state, except, so those that we say except, it means that they are insoluble. So all sulfates are soluble except lead 2 sulfate, barium sulfate, and calcium sulfate, which is slightly or sparingly soluble. So you see, among the exceptions that we say are insoluble, lead 2 sulfate has been mentioned, meaning that once we write the chemical equation, lead 2 sulfate will be insoluble. And if it is insoluble, it means that in the state symbol, it will have a small s into bracket. For magnesium nitrate, we say that all nitrates are soluble. So even magnesium nitrate is among them. So it will be soluble and in the aqueous state, a small a and a small q into bracket. So next we have a chemical equation for the same word equation. So this is actually the word equation. So we then write the chemical equation for that reaction. Here is where we use the chemical symbols for all the reactants and all the products. And we begin with lead 2 nitrate. So we have Pb, and then with the nitrate. In case you have a problem with the writing of the chemical formulas, there is a previous topic that was all about that. Then you'll know that for lead 2 nitrate, lead has valence 2, nitrate has valence 1, then they exchange the valences, you end up with this formula. So in case you have a challenge on that, there is a lesson that can guide you on that. So you are not late. You can post this video and then first of all go back there, learn more about the writing of the chemical formulas, then you come back and you'll have an easy time following on. So lead 2 nitrate, we already say that all nitrates are soluble, so this one is in the aqueous state. And for the state symbol, we don't write them below here, we write them on the same line in a way that if you were to draw a straight line, nothing will be below there. So plus magnesium sulfate, this is the symbol for magnesium, the M should have sharp corners, then sulfate, and all sulfates we have just said are soluble except lead 2 sulfate and barium sulfate, while calcium sulfate is sparingly soluble, so meaning magnesium sulfate is in the aqueous state. Then we got the product side where we have lead 2 sulfate, we say the lead 2 sulfate is in the solid state because, as we said, all sulfates are soluble except lead 2 sulfate, so it is mentioned among the exceptions that are insoluble, so it is in the solid state. Then plus magnesium nitrate, again all nitrates are soluble, so in the aqueous state. So I hope you can see, and I hope that you're also writing everything so that step by step we be together. So that is lead 2 nitrate in the aqueous state, magnesium sulfate in the aqueous state. So because the reactants should be soluble, so in the aqueous state both of them, for the product side, one of them should be a precipitate in soluble and in the solid state, and that is what we have there for red 2 sulfate rather. Then for magnesium nitrate, it is the soluble salt on the product side. So down here we can say into bracket that this is soluble, this is also soluble, forming an insoluble salt and another soluble salt. So that was actually a part of the NB that we had previously, that we have two soluble salts reacting and we end up with one insoluble salt and another soluble salt. So we can now go to the balancing of the chemical equation. So let us begin. From this point where we have the tail of the arrow, we say that this is the reactant side, and from the head of the arrow, the other direction, that is the product side. So once we begin to balance, we should make sure that any substance that is represented on the reactant side should be with an equal number with the same substance on the product side for them to be balanced. So we begin with red. How many red are on the reactant side? We have 1. Why 1 and we have a 2 here? It's because this 2 does not belong to red, it belongs to these elements that are into bracket. So red is just 1. We go to the product side. Again, red is just 1. So let us write the formula. We are not supposed to have the letters very close, so red is 1. So we put a tick to say that we have already balanced that element. We go to nitrogen. I like it when we follow the order. We don't jump from lead, then we go to magnesium to, we might forget some of them. So we begin from the very left side. We start with the red, then go to nitrogen, go to oxygen, go to magnesium, like that. So to be orderly. So we are next to nitrogen. I have just said that these two belongs to both nitrogen and oxygen, so nitrogens are 2. We go to the product side. We check how many nitrogens we have. Again, when you check this point, we also have these 2 that is also for nitrogen, and the nitrogens are balanced. Next we go to oxygen. From this point we have 6 of them because these 2 belongs to both the nitrogen and oxygen. So, and oxygen in the bracket we had 3, so 3 times 2. So oxygens there are these 6 plus these 4. Don't forget that we have others for on this part, so they are 10. When you go to the product side, how many are they again? We have these 4 and you have these 6, so they are also 10, so well balanced. Then we go to magnesium, having a sharp corner on both tops. Magnesium is just 1. Going to the product side, we check on magnesium, it is again just 1, so it is also balanced. Finally we have sulfur. We are saying finally because we already took care of oxygen when you are balancing the oxygens. So sulfur again is just 1. Why 1 and we have a 4 here? It's because this 4 belongs to oxygen. So sulfur 1. On the product side, we again have 1 sulfur. because this 4 belongs to this oxygen. So sulfur again is just 1. So meaning that our equation is self-balanced. There are those equations that we say are self-balanced, meaning there is just the way they are, everything is already balanced. So when you're writing such an equation, you are supposed to indicate somewhere that it is already balanced. Already balanced. So you're not supposed to leave it just like that. At least write it is already balanced. Because when you leave it like that, no one will know whether you left it like that because it was too hard for you to balance, or because you had no time for it, or no one will understand that you actually balanced it and you saw that it was already balanced. So indicate there that it is already balanced, because other times you get equations where you are needed to write numbers at these points. But for our case, it is already balanced. So write it down there that our equation is already balanced. And actually make sure that everything, any working that you're having, everything that you're balancing, you indicate it there and you keep on putting a tick. That one will make it easier for you when you're checking on which one is not balanced and which one is balanced on which side. So let us go now to the real ionic equation. Next, we need to analyze this well-balanced chemical equation and check on those substances that are in the aqueous state, and then break them each into its respective ions. The only one that will not break is the one that is in the solid state, because it is already insoluble, it is already a precipitate. So we go now to the equation where we have red 2 nitrate. This is the metallic part, this is the radical. We need to break it into 2. Then we have magnesium and the sulfate radical. Magnesium being the metallic part, this is the radical. We need to break them into 2. This one will not be broken now that it is the precipitate. It is actually white in color, so it is a white precipitate. So this one will not be broken. It will not. It cannot even break because it is already in the solid state. The only ones that can break easily into their respective ions, they are those that are in the aqueous state. So we got to this one. It can also be broken. This is a metallic part, and it will be broken at that point into the radical and the metallic part, each one separately. So we come back here. We say that red will have 2 positive aqueous. Where is this 2 positive from? You remember the name of this substance is red 2 nitrate. So that 2 mentioned in the name is taken to be the valency for red. It is also, and when it is a valency, it means that red being a metal, it can lose 2 electrons. So that is why we have 2 positive at the top. Then we have the nitrate ion. The nitrate ion is written like that. So you need also to go back to a previous lesson somewhere and check the formulas for various radicals. So the nitrate ion is written like that. And then to balance the charges, that is why we have nitrates with a 2 here, meaning nitrates are 2. Because one nitrate is having 1 negative, so we can only have 2 of them to have this 1 negative times 2, 1 negative times 2 to have a negative 2, so that all of these, the nitrates, because they are 2, all of them, the 2 of them will have 2 negative, negative 2, and now adding to this one, positive 2, we get a 0 because the overall charge for the whole of this lead 2 nitrate is supposed to have an overall charge of 0. So red with the two positive and the nitrates are 2, so one nitrate with one negative like this, and there are two of them getting a negative 2. Now adding to this one for red, we should have an overall charge of a 0 for such compounds like red 2 nitrate. The same will happen with magnesium sulfate. So we got to it. Magnesium, remember it is in group 2. It loses 2 electrons, so with a charge of 2 positive, again in the aqueous state. Remember also the formula for the sulfate ion. It is written like that. Again, we write it in the aqueous state. To balance the charges, this one is +2 and this one is -2 mathematically. So already here we have an overall charge of 0, though we are not supposed to write it. You should not get confused and think that this 0 should always be here. I'm just explaining that for these substances, the overall charge is 0. So, and to get the 0 that is supposed to be the overall charge, then it comes from how we balance the charges. So magnesium with the 2 positive and the sulfate with the 2 negative, mathematically you say this one is +2 and this one is -2, and you have your 2 shillings and you had a debt of 2. What do you remain with? A 0 in your pocket. So the overall charge becomes a 0. This one we said that it cannot be broken, so we write it as it is. We write it as it is. Then we go to magnesium. Magnesium with a 2 positive, aqueous, and the nitrate ion. It is in the aqueous state and we have 2 of them. So once you write it like that, you then check on the balancing of the ions. So for magnesium we have +2, nitrate has a -1 and there are 2 of them, so having a -2, so you come here and say -2 for these 2 nitrate ions. So again the overall charge up here is supposed to be a 0. So that way all the ions are all balanced. Their charges are already balanced. So now from what we have just written, we can determine which of the ions have not taken part in the chemical reaction. And how do you do it? You check on the state symbol. Any one of them whose state symbol has not changed from how it was in the reactant side to how it is in the product side, you say that that one is already a spectator ion. Remember how we do it in a football match. There are those players that are in the field and taking part in the football, and there are other people who are cheering on the sides, and we call them the spectators. So by the end of the football match, the spectators will not have taken any part in the playing of the ball. So the same happens in an ionic equation. There are those substances that take part in the chemical reaction. There are others who are just there, facilitating in a way because they must be there anyway, but they will not have changed at the end of the equation. So let us check on lead. Lead, to begin with, in the reactant side, we have it as capital P, small b, 2 positive, aqueous. Checking it in the product side, we do not have any lead that is with a 2 positive at the top. It is already combined in the product side with the sulfate. So that one tells us that red took part in the chemical reaction. Let us go to nitrate. In the reactant side, nitrate is 2NO3 negative, and we forgot to put the aqueous. It is very important. We put the aqueous there. So 2NO3 negative aqueous, and on the product side we have it the same way, 2NO3 negative aqueous. So that one did not take part in the chemical reaction, so we can cancel it. So you come there and cancel it. You go to the other side and also cancel it. Then we go to magnesium. And actually the line that I have put, a diagonal line must be there. It is usually not indicated in our KRB book 2, so you need to go there and also correct. That is a printing error. So we go to magnesium. We have capital M, small g, 2 positive aqueous. That is in the reactant side. On the product side, we have it the same way, a capital M, small g, 2 positive aqueous, meaning it did not change. So we again cancel it. We also cancel it like that. Then we go to sulfate. In the reactant side, we have it as capital S, capital O, 4, 2 negative aqueous, but for the product side, it has changed. It has already combined with the red 2, and now combined we have red 2 sulfate. So that one we cannot cancel. So we then finally go to the ionic equation. Remember at the beginning we said that in the ionic equation we only include those substances that took part in the chemical reaction. So we begin with red, and it is a must we start with the metallic part. So we have red, 2 positive aqueous, combining with the sulfate that was also not cancelled, 2 negative aqueous, to form this red 2 sulfate, which we said is the white precipitate. And so finally we have the ionic equation, where we have Pb 2 positive aqueous reacting with SO4 2 negative aqueous to get lead 2 sulfate in a solid form. So that is the precipitate, and that is the insoluble salt. Remember, ionic equations are formed during precipitation reactions. Finally, we have this assignment for you. When silver nitrate and lithium chloride react, a white precipitate is formed. Roman 1, identify the white precipitate, and Roman 2, write an ionic equation for the reaction. Make sure that you try this one, and in the comment section you can write the ionic equation that you determined, and I will tell you whether you did it the correct way or not. In case of any difficulty, remember, I always tell you that I'm a comment away from wherever you are. If you're new in this channel, kindly subscribe. It is very free. Keep on working hard. Hard work pays, and I believe that one of these days you will smile all the way to your university of choice and to your best career ever. Keep it right here. Keep on telling me which other topic or which other subtopic you find challenging, and I will gladly prepare you a lesson on the same, explaining and simplifying chemistry concepts to the level that you can understand easily. So I really wish you the very best. Let us meet in our next lesson. God bless you.